Hello, everyone, and welcome to another episode of Echo Live here at the Michigan Science Center, brought to you by our Echo Distance Learning Program. My name is Paulette, and I will be guiding our virtual planetarium show today. If this is the first time joining us, go ahead and introduce yourselves in the chat. And for some of our old friends, introduce yourselves as well, just to remind us that you're here. Now, I know everybody is sort of getting ready to gear up for school, whether it be virtual school or in-person school. And so we're excited to be reaching the end of our summer programs, but we'll still be continuing to do Echo Live for the next couple of months. So we are so excited for you all to be here today. Once again, if you are just joining us, go ahead and introduce yourselves in the chat. The chat feature is going to be the best way to communicate with me throughout our program today. So if you have any questions or need to answer a question that I'm asking, you can ask that through our chat feature, and I'll be able to communicate with you there, whether it be on Facebook or on YouTube or on Zoom itself. We'll be able to answer any questions that you might have during our programs today. Now, today we're going to be talking about something pretty cool. We are going to be talking about satellites. So we're going to be talking about satellites. And does anybody know what is the definition of a satellite? What is the definition of a satellite? We've talked about satellites on Echo Live before, and we've actually talked about one really big satellite in the past as well. So what is the definition of a satellite? For those of you that don't know, a satellite is an object in space orbiting around a planet. So we talked about the definition of planet when we did our Pluto episode. So a planet is a huge object in space that is shaped like a ball or spherical, and it clears its orbit and it's orbiting around the sun. Now, if it were orbiting around another planet, that makes it a satellite. So you might have heard about two different types of satellites. We have our natural satellites, and we have our artificial or man-made satellites. Our natural satellite that we have orbiting around the planet Earth is the moon. And our artificial satellites, we actually have a ton of those satellites in orbit. So today we're going to be taking a look at some of those satellites, along with some of the really cool things that we can learn from our satellite imagery. Evan from Texas, it's so good to see you in our chat today. Again, if anybody wants to introduce themselves into the chat, I'll be asking questions throughout the program, and I would love to answer any questions that you have throughout the program as well, if you have any. So we're going to switch on over to our virtual planetarium, and we're going to go ahead and take a look at something that might be familiar to some of you. So if we take a look here, this might be familiar to some of you, maybe not everybody. I know our friend Evan from Texas is living all the way down in Texas, so he probably doesn't quite know what we're looking at right now. But right here, we're looking at the Michigan Science Center. So I'm here in the Michigan Science Center right now, and I'm actually right here at the very edge of our planetarium. Our planetarium is currently closed, but we're still able to bring you these fun virtual planetarium programs. The Michigan Science Center is, of course, open to the public, so come check us out if you are in the area. So here we have the Michigan Science Center and our planetarium. We are going to start to move away from the Earth. As we move away from the Earth, we're going to start to see more and more of our city of Detroit. And there we go. So here we have the city of Detroit, and we're starting to see the Rensen in downtown. We'll start to be able to see the Detroit River. And as we continue flying up, all of the images that we're looking at right here were actually taken with satellites. Now, these images are not updated every single day. These images that we see, these close-out views of the ground, are actually taken periodically throughout the year. Usually it's about once a year or so. And you can actually see those satellite images when you use something like Google Maps and you zoom on in to the area that you live in. All right, so here we are on the taking a look at our Earth. Now, if we keep going out, we're going to start to be able to see some of those satellites again that we were talking about. There we go. But it would also help if I turned those satellites on. So we're able to see the Earth, and the Earth is looking pretty nice actually right now. We have our cloud layer on top, and of course all of these images that we see of the Earth are taken with satellites that we have out in space. So if I turn on some of our satellites, we're going to be able to see the ones that are fairly close to the Earth. Now, we say that these satellites are in something called LEO. These satellites are in something called LEO. Does anyone know what LEO stands for? These satellites are in LEO, L-E-O. What does that stand for? The satellites are in LEO. It stands for low Earth orbit. So these satellites are in low Earth orbit, very, very close to the Earth. And when we take a look at satellites in general, we're going to be able to see that the satellites come in a couple of different distances. Satellites are either in low Earth orbit or the LEO zone, medium Earth orbit or the MEO zone, or high Earth orbit right up over here. So there's several different types of satellites that are out there. And specifically the ones in low Earth orbit are the ones that are fairly close to us. Geosynchronous satellites or GPS systems. Does anybody use a GPS at home? To get from point A to point B, do you use a GPS? I know I do. I use a GPS all the time, and I have a GPS right here in our studio. I've got a GPS right here on my cell phone. It helps me get from point A to point B. So GPS satellites are in what we call geosynchronous orbit in medium Earth orbit. So they're far enough away from us that they're actually able to stay in the same spot as the Earth turns on its axis. And we'll talk about that more in a little bit. We also do have some satellites that are in high Earth orbit in something that we call a Lagrange point. And that's just something that you might hear. There's one here between the moon and the Earth, and there's actually another one on the other side of the moon. So when we launch the satellite there's going to be a satellite that's launching eventually in the a telescope called the James Webb Space Telescope. That's actually going to be in the Lagrange point all the way out here on the other side of the moon, so that we'll be able to see a lot more. Now, one of the satellites that I really wanted to talk about today is the very first artificial satellite of the Earth? Does anyone know what we called the very first artificial satellite of the Earth? I think it's got a pretty cool name. It was launched in 1957, and it was not launched by the United States. It was launched by another country. It was launched by Russia. Does anyone know the name of this artificial satellite that was the very first satellite that we ever launched into space? What is the name of the very first satellite that we launched into space back in 1957? Like I said, it was launched by the Russian Space Agency, not us here in the United States. It was launched during something that we call the Cold War, and we were trying to launch things into space because these satellites, you saw some of the amazing images that we have of the Earth. They could be used for things like spy satellites. So Russia and the United States were fighting with each other and trying to get the first satellites up into space so that they could see some of those amazing images and using them as spy satellites. So this right here is called Sputnik. Sputnik was the very first satellite that was put into orbit. It was up there for a couple of months before Sputnik actually came back down into our atmosphere. And Sputnik was launched right here into low Earth orbit. Now, you might notice some other satellites that are in low Earth orbit as well. Like this one right here, we have the International Space Station. The International Space Station is in low Earth orbit. And low Earth orbit is actually getting kind of crowded. Low Earth orbit is getting kind of crowded because we're tossing satellites up there. Ooh, left and right. We're doing this all the time. We're throwing satellites up into space. We use those satellites for communications. We use those satellites for internet. We use them for being able to track our weather. We use them for being able to track the temperatures of the oceans, the carbon dioxide in the atmosphere. We use these satellites for a lot of different things. So this one right here is actually a satellite that we have up there that's pointing away from the Earth. So not all satellites that we have are pointing towards the Earth. This one is the Hubble Space Telescope. And this telescope has actually allowed us to see a lot of different things in space. So this one is pointed out the opposite direction. But it is, again, in low Earth orbit. Now, we're going to zoom out in our virtual planetarium to be able to see to be able to see some more of our satellites. So if we bring up the next couple of satellites, we're going to see our geosynchronous or our geo satellites. All of these are part of our Global Positioning System, or GPS. Some of these satellites are doing some other things as well, like if anybody has satellite TV. Satellite TV is actually using these satellites as well. You take your satellite dish outside your house and you point it at one of these lovely satellites right here. And because these satellites are in geosynchronous orbit, they will always be facing the satellite dish will always be facing that satellite. Because essentially what's happening is essentially what is happening is that our satellite is like right here. And if, for example, I start orbiting on my axis, luckily I have a spinny chair here in the planetarium. If the satellite stays right here in this spot as the Earth turns, I'm going to be looking at that satellite once a day. Now, most satellites are in orbit around the Earth, and some of those satellites actually around the Earth, and some of those satellites actually orbit around the Earth at the same speed we rotate on our axis. So we're always going to be pointing right here at those satellites. So that's why our satellite dishes and our satellite TV works. And so we're going to be talking a little bit about mostly low Earth orbit and some of the issues that we are having in low Earth orbit with all of these overcrowding. Now, I talked about Sputnik, and I said that Sputnik falls back to the Earth, right? So Sputnik fell back to the Earth, burned up in our atmosphere, and hit the ground. And that can actually be kind of dangerous. A couple of years ago, we had a satellite that was making its way back into orbit, and it hit the news. It was a pretty big deal. We track most of the stuff in low Earth orbit because it can be really, really dangerous. There is something in low Earth orbit because some of these satellites don't work anymore. Some of these satellites have exploded. And there's something that we call space junk. So you can see all of this debris and broken up stuff in low Earth orbit can be a little bit of a problem because that stuff is orbiting around the Earth. And these satellites are orbiting around the Earth. And what happens if that stuff is orbiting around the Earth at a different speed than the satellites that are orbiting around the Earth, and then all of a sudden we have a collision? That can be really bad, and it's happened before. We've actually had collisions happening in low Earth orbit. That's why some of our satellites that are up there are kind of all broken down. If you've ever seen the movie Gravity, Gravity was about a lot of that space junk that's up there. Super, super dangerous, especially because remember, we have human beings living in low Earth orbit. Our friend Chris Cassidy is up there right now. He's on the International Space Station along with a few other astronauts. So they're on the International Space Station, and this space junk is actually really threatening to them because this space junk could puncture a hole in the side of the International Space Station. And though we haven't had that happen yet, it is still a possibility. And this is why we actually, the NASA actually watches these debris particles out in space. They watch every satellite, every piece of debris that they possibly can, and they are trying to track that debris. But most of this debris and most of this stuff that's a problem is actually because these satellites are no longer operable. So they're not working anymore, or it's just stuff from explosions or collisions or something like that. So one of the things that scientists have been thinking about and really trying to work towards is using technology engineering to try and figure out how to clear out some of this space junk. And then, of course, we're trying to figure out what we do with that space junk. Do we collect it and bring it back to the Earth? Do we collect it and shoot it off into space so it's somebody else's problem? Well, we are sort of using our feats of engineering to decide that, but we're also sort of running into an ethical problem, sending that debris off someplace else for it to be someone else's problem in the future. So this is something that the next generation of engineers are going to have to solve. They're going to have to figure out, how do we get this space junk, this problem out in space, and how do we get it under control? Not just by watching the debris and the satellites that are out there, but actually solving the problem in the future. Now, if we take a look at what the Earth has looked like over the years, I said we've been launching more and more satellites all the time. So 1957 is when we launched Sputnik 1. And so, around the Earth, we did have a couple of satellites because we were able to launch a few more after that, as was the Russian Space Agency. And so there were a few satellites around. In 2005, there were way more. In 2018, it got even more crowded up in low Earth orbit. And if we continue going along the trajectory that we're going, by 2030, it's going to be very, very full of satellites. I was actually watching the movie WALL-E the other day, and when they take off in the ship to go to take Eve to the mothership, they actually bounce into a whole bunch of space junk on the way. So it'll be interesting to see what low Earth orbit looks like in the future, especially if we keep going along this way. Now, the other problem with satellites is the fact that you can actually see them up in the nighttime sky. Has anybody seen a satellite before when you look up into the nighttime sky? I know I've seen a satellite before, and some of them are really interesting. So what you'll see when you see a satellite is you'll actually see the stars, and then you'll see something that looks like a star moving. It won't be moving like an airplane. Airplanes move really, really, really quickly, and they flash their lights. So it won't be like that. But it'll just be moving smoothly across the sky. And so we can actually see satellites. And I was out in the middle of nowhere a couple of weekends ago going camping, and I was able to see probably about 20 satellites just in the hour that I was sitting out there. And that's a lot of different things to be able to see, and it might block our view of the nighttime sky. Specifically, there's actually some controversy going on about something called the Starlink satellites. The Starlink satellites are satellites that are being put into space by Elon Musk and his company, SpaceX. And so they're putting up all of these satellites, and they're actually doing it a little bit under low Earth orbit, so not quite where all of the other satellites are in our low Earth orbit. But he's trying to put 12,000 satellites into orbit. And it'll be interesting to see what those satellites look like over time. They might actually block our view of the nighttime sky. So we'll still be able to see the satellites, we'll still be able to see some of the stars, but it might get really confusing which is a star, which is a satellite. And so that's one of the things that we're facing right now is, okay, so we want to launch these satellites, and the Starlink satellites are really cool. The Starlink satellites are trying to give us internet across the globe. So super cool. But we're running into the problem of like we're going to be able to see these satellites up in the nighttime sky. So how do we solve this problem? They've actually started painting the satellites that they're sending up into space with a less reflective paint that's going to be facing the Earth. So that's one way to make it so that we're not seeing these satellites. But it's going to, again, take another set of engineers to figure out, okay, now what do we do with these? How do we block our view, or how do we not block our view of the nighttime sky? Now, something that these satellites do that is super, super cool is these satellites take a look at the Earth. I mean, some of them do take a look at what's happening out in space. But some of these in particular are taking a look back at the Earth and telling us things about our climate, our weather, what's happening on the Earth, stuff like that, natural disasters. So what we're going to do is we're going to fly back into the Earth, and we're going to take a look at some of the things that are happening on our Earth right now. So there we go. We zoom on in. We get rid of our satellites just so that they are not blocking our view. There we go. And we're going to go ahead and take a look at the Earth let's see. Actually going to go over to, oh, that's on the nighttime side right now. Let's go over to the United States. So Evan from Texas mentioned that they are very, very lucky. And that's because there is actually a huge hurricane, a Category 4 hurricane. And that hurricane right now is headed straight towards Louisiana and Texas. This hurricane is incredibly dangerous. And one of the ways that we watch hurricanes is by these weather satellites. They are actually able to watch these hurricanes over time, and they're able to see the temperature of the water so they can see if it's going to get bigger or smaller as it moves along. They can also see when these tropical depressions start. Usually those tropical depressions actually start way out here near Africa and move their way across the Atlantic Ocean into this area. Some hurricanes go up the coast right here. And we even have some remnants of a hurricane up over here, very, very, very far north. But right here we can actually see Hurricane Laura. And Hurricane Laura, like I said, is really, really dangerous. And so if you're in the path of the hurricane, please make sure to evacuate before it gets to you. But if you are not, just please be careful and make sure that you're safe. So Evan, that goes for you. So if we look right over here, we're also going to be able to see something interesting that's been happening in the United States right now. You might be able to see, it's really faint, but you might be able to see that this isn't clear. There's a few clouds here and there, but there's also a ton of smoke. So we have wildfires that are happening right now in California, Colorado, and Arizona. Those wildfires are producing smoke that can actually be seen from space through these satellites that we use. So these satellites allow us to take a look at the Earth, track our weather, track a lot of other things. We can also see how the Earth changes over time, because we're constantly taking pictures. We use these satellites in low Earth orbit to look at the Earth and to look at things beyond. We use the satellites in geosynchronous orbit for things like our satellite television and our global positioning system, or GPS. We're using these satellites literally all the time, and they're really, really important to us. We do need to understand and work together along with our next generation of scientists and engineers. We need to understand that these satellites, however helpful, can also be a problem in the future. So we have things to solve like space junk and making sure that low Earth orbit is safe for our astronauts that are still up there. And we need to make sure that we don't overcrowd and block our view of the nighttime sky. So satellites are fairly new to us. Like I said, we only launched our first one in 1957, and we still have a long way to learn about how these satellites can help us, but also how they can hurt us in the future. So this is a great example of responsible engineering and responsible science, understanding what some of the problems might be and trying to mitigate or solve as many of those problems as we can before moving forward into the next stage. All right, so we've come to the part of our program where it's time for me to see if anybody has any questions. So anything that we talked about today, satellites, anything that's in low Earth orbit or geosynchronous orbit. And while we're doing that, I'm going to go ahead and thank our sponsors. So Ford and Denso have been pretty awesome, and they have sponsored our Echo Live program all summer long. Like I said, we're starting to wrap up our summer season and head into fall. I know most of you are getting ready to go back to school. If there is a time or a day of the week that works better for you, let us know. Email us at the Science Center info@my-sci.org and let us know if there is a better time for us to be doing these Echo Live programs, especially with everybody going back to school. We want to do what's best for you. So, not seeing any questions coming through, I want to thank everybody for joining us here today and learning a little bit about satellites, space junk, all sorts of really cool things. And I hope to see everybody next week for our next Echo Live program. Echo Live will continue to be on Tuesdays and Thursdays. We are still, like I said, just wrapping up our summer season and planning for the next couple of weeks. So if you have input, please let us know, and we're happy to take that input. So, all right. Thank you so much, everybody. And we hope that you have enjoyed the program, and we'll see you next week.